Alright guys, welcome to today's tutorial. So let's say you are to compute the Taylor representation of ln x, that's the natural logarithm of x near c equals 1, and use Taylor polynomial to approximate natural logarithm of 1.1. So how did you go about it? So the first thing is by you write out the Taylor series, which is f of x equals f of c, then plus f prime of c as the first derivative, x minus c over 1 factorial, plus f prime prime, that's the second derivative of c, x minus c square over the 2 factorial, then plus the third derivative of c, then x minus c raised to the power of 3 over 3 factorial, then plus the fourth derivative of c, then x minus c, that is over 4 factorial, then plus the fifth derivative of c, then x minus c over the fifth factorial, then plus continuously like that. So since f of x is given as ln x, so therefore you need to find the first derivative of x, which is differentiation of ln x, that's 1 over x, and you differentiate it again, that will give you the second derivative, which is going to be minus 1 over x squared. Then you find the third derivative. The third derivative is you differentiating minus 1 over x squared, which is 2 over x cubed. Then you find the fourth derivative, so which is going to be minus 6 over x raised to the power of 4. That is, you differentiate 2 divided by x cubed. Then you find the fifth derivative. The fifth derivative is u differentiating minus 6 over x cubed. That's going to give you 24 over x raised to the power of 5. Alright, so you can therefore go to transform it as f of c. So f of c will be equal to ln c. And what is c? C is given from the question as 1. So ln c is 0. So then continues like that, f prime of c, which is going to be 1 divided by 1, because c is 1. So it's going to give us 1. Then the f prime prime of c is going to be minus 1 divided by 1 square, which is going to be minus 1, and f prime prime, that's the third derivative of c, which is going to be 2 over 1 raised to the power of 3, and that is 2. Then the fourth derivative of c, which is minus 6 over 1 raised to the power of 4, and that is minus 6. Then the fifth derivative of c, that's where we are going to stop, that's going to give you 24 divided by 1 raised to the power of 5, which is equals to 24. So let's head on to the next page. So since we have that, from the question, x is given as 1.1, because we have to find the approximate for ln in, that is the natural logarithm of 1.1. So therefore x is 1.1, and c is given in the question as 1. Therefore x minus c will be equal to 1.1 minus 1, which is equal to 0.1. So at this point, you are going to compute this value into the equation we have. So we can thereby say that f of x is equal to, that is f of c, which is 0, because f of c is 0, then plus 1 into 0.1 over 1 factorial, which is 1, then plus minus 1 into 0.1 square over 2 factorial, which is 2 times 1, then plus the f prime of c, that's the third derivative of c, which is 2, then into 0.1 raised to the power of 3, then over 3 factorial, which is 3 times 2 times 1, then plus, that's minus 6 into 0.1 raised to the power of 4 over 4 times 3 times 2 times 1, then plus 24 into 0.1 raised to the power of 5 over 5 times 3 times 2 times 4 times 4 times 1, so which is going to be 0. Though 0 is cancelled, then you have plus 0.1 then minus 0.01 divided by 2, then plus 2 times 10 raised to the power of minus 3 divided by 6, then plus, minus, that's minus 6 times 10 raised to the power of minus 4 divided by 24, then plus 2.4 times 10 raised to the power of minus 4 divided by minus 4 divided by 120. So an f of x is lean or natural in 1.1, so which is going to be 0.1 minus 5 times 10 raised to the power of minus 3, then plus 3.3 times 10 raised to the power of minus 4, then minus 2.5 times 10 raised to the power of minus 5 plus 2 times 10 raised to the power of minus 6. So by adding everything together, you're going to have 0.095307. So that is the approximate value. Alright, let's go on to the last example. So compute the Taylor representation of e raised to the power of x, near c equals 0, and use the Taylor polynomial to approximate. So we have to use the Taylor polynomial to approximate e raised to the power of. So write the polynomial, the Taylor polynomial, which is f of c, then plus f prime of c, then x minus c over 1 factorial, then plus f prime prime of c, then x minus c square over 2 factorial, then plus f prime prime of c, then x minus c raised to the power of 3 over 3 factorial, then plus f of the fourth derivative of c, then x minus c raised to the power of 4 over 4 factorial, then plus the fifth derivative of c, then into x minus c raised to the power of 5 over 5 factorial, then continues like that. So at this point, your f of x is given as e raised to the power of x. So you need to find the first derivative, the second derivative, the third derivative, the fourth derivative, and the fifth derivative. So the first derivative is going to be the same thing, the second one the same thing, third one the same thing. That is, if you differentiate e raised to the power of x, you still have e raised to the power of x. So therefore, then for the f of c, so it's going to be e raised to the power of 0, which is equal to 1. Then f prime of c, that's going to be e raised to the power of 0, that's also 1. F prime prime of c, that is the second derivative, e raised to the power of 0, which is 1. And the third derivative of c, which is going to be e raised to the power of 0, which is going to be 1. And the fourth derivative of c, which is going to be power of 0, and that is 1. And the last one. So at this point, you can compute this into the formula. So you computing it, before we compute into the formula, we have our x is given as 0.5 and c is given as 0. So therefore x minus c will be equal to 0.5 minus 0, which is equal to 0.5. So at this point, we can put in our f of c, which is equal to, this is same as 0.5, that's what we have to solve, will be equal to the first one, that is f of c, which is given as 1, then plus, then the second f of c, that's the second derivative of c, which is going to be 1, multiplied by x minus c, that's 0.5 over 1 factorial, then plus the second derivative of f of c, which is 1 also, then to 0.5 raised to the power of 2 over 2 factorial, that's 2 times 1, let's just say 2 times 1, then plus the third derivative of c, then into x minus c raised to the power of 3, that's 0.5 cube over, that's 3 factorial is 3 times 2 times 1, then plus 1 also into 0.5 raised to the power of 4 over 4 times 3 times 2 times 1, then plus 1 into 0.5 raised to the power of 5, then over 5 factorial, which is 5 times 4 times 3 times 2 times 1, then continuously like that. So e raised to the power of e raised to the power of 0.5 will be equal to, that's 1, then plus 0.5 divided by this is going to give 0.5, then plus 0.5 squared is going to be 0.25, then over 2, then plus 0.5 cube is going to be 0.125 divided by 6, then plus 0.5 raised to the power of 4 is going to be 0.0625 divided by 24, then plus this is going to be 0.03125 divided by 120, then continues like that. Then e raised to the power of 0.5 will be equal to 1 plus 0.5, then plus 0.25 divided by 2 should give you 0.125, then plus 0.125 divided by 6 is 0.0208, then plus 0.0625 divided by 24 is 2.6 times 10 to the power of minus 3, then plus 0.03125 divided by 120 is 2.6 times 10 to the power of minus 4. So therefore the approximate value of e raised to the power of 0.5 is 1.648660. Thank you guys for watching. If you like this video, make sure you like, comment, share and subscribe. I'll see you in the